guys and good morning. This is short 3D video presentation for my submission technical challenge or TC11 organic acid corrosion prevention and mitigation for carbon steel topside piping and equipment. My name Wan Ahmad Fairuz bin Wan Abdullah. Short information on myself. I'm used to work with United Kingdom company names Gulf Keystone Petroleum International as senior production chemist. Previously, I'm working at Petronas Carigali Iraq Holding BV or PCI HBV for 4 years as laboratory supervisor and production chemist, taking care of routine and specialty analysis for hydrocarbon, water injection, environment and utility. Before Petronas Iraq, I'm serving 5 years in Talisman Energy Malaysia as platform chemist and production technician. Before that also, I'm working at ANSI platform for 5 years as water injection and laboratory team leader. My TC11 proposal summary is to prevent and mitigate organic acid corrosion to the carbon steel upstream topside piping by neutralization chemical-based method. This method incorporates advanced fine-tuning effectiveness chemical-based selection and detection using sophisticated equipment, ion chromatography, liquid chromatography, mass spectroscopy or LCMS, and rotary cylinder electrode or RCE, linear polarization resistant LPR, total acid number TAN, hash, and several lab analyzer. Let's start with video presentation. We can see here model of one platform, mother platform, and the smaller platform is the satellite jacket platform, and it contains the wellhead. For the fuel stream flowing from satellite to mother platform for processing, our activity started with preliminary offshore site visit and preparatory work field trial to identify suitable injection point and representative sampling point. Then we checking the injection point if available with the quill and atomizer at the jacket platform to the fuel stream export to mother platform. For the sampling point, we should identify the suitable and representative sampling point for the LPR or linear polarization resistant tapping point. Then we perform the LPR measurement for the 6 hours at the selected point and record the data as a LPR baseline 1. To get the confidence data for the LPR measurement, we should perform it before and after pigging activity. This is because we need to ensure the pipeline is free from the sludge which may contain the biofilm from the SRB or MIC microbial induced corrosion and prevalent with the corrosion occurrence as interference. Sample of fuel stream before and after will be taken to onshore for analysis. Just to make sure the integrity of the sampling, remember the precaution prior to take the sample. Need to stop the particular chemical injection at the wellhead. For the example, chemical demulsifier need to be stopped for the 15 minutes and corrosion inhibitor to be stopped for injection for the 2 hours. This is to ensure the sampling are not contaminated with the chemical and to prevent the haywire data. Use only clean and new container for the sampling. And for the on-site analysis also, for example in here, we need to perform the tests such as CO2 and H2S for the vapor for every sampling point. We can use the gas tank or dragger hand pump equipment. Then for the wet analysis, example is alkalinity and total dissolved iron, nickel and pH need also to be performed here. Since interference of organic acid corrosivity measurement can be affected by MIC or microbial induced corrosion, then we need to perform the SRB and GAB analysis as per API RP38 MIC mapping, which include the enumeration and inoculation for 14 days at least. There is several sample required analysis at onshore and using sophisticated equipment. Sample from either satellite and receiver at mother platform will be analyzed for several parameters such as 12 iron, volatile fatty acid or VFA, bottle test for the chemical base titration to find the best ingredient to minimize the specific type of organic acid. Total acid number and liquid chromatography LCMS is to identify the overall type of organic acid contents in particular sample. For the analysis, we will performing the RCE or rotary cylinder electrode or any equivalent corrosion cell as per ASTM D1384 or equivalent. Amount of sample required must be adequate as per my submission paper. Once we got the data analyzed from on-site and onshore laboratory, we will make interpretation to determine way forward in terms of selection chemical treatment for the field trial. In the basis, selection type of base will be based on the bottle test titration result from onshore laboratory, supported by LCMS, TAN, RCE, and other data. We took example such as DOBA oil field. Type of chemical selection may be 3-ethylene methyl ammonium methyl carbonate or 3-ethylene methyl ammonium hydrogen carbonate or 3-butyl methyl ammonium methyl carbonate or other active recipe on base which is economical that can be used for Malaysia food waste stream. All of this depend on the study soon. To simplify the explanation, let's take the example of this data, which indicate before and after titration with chemical base. From the data, we expecting the reduction of organic acid after chemical base injection. Reduction of organic acid should proportional with corrosion rate given treatment with no interference with microbial induced corrosion SRB. In the function of temperature, effect corrosion rate are reduced at lower concentration or organic acid. This is very basic figure that we can found in most of the study. In the fine chemical, ferrum carbonate formation is well known to protect the pipeline and significantly lower down the corrosion rate. Reduction of organic acid content will increase precipitation of ferrum carbonate chances. Precipitation of ferrum carbonate proportionate with the reduction of the corrosion rate. From the figure, this is the example of the figure. Then we can see the trending example of expected the corrosion rate increase with the acetic acid content. This is KSC corrosion modeling was used for acetic acid sensitivity study based on the field condition. The model condition were 100 degrees Celsius at 70 bar, and we found the corrosion rate is greatly proportionally reduced with the content of the organic acid. There is other several trending that I put in the submission paper, and we can explain further during mocking session. Last part of the video presentation was KPI setting proposal to sustain effectiveness in mitigating corrosion by organic acid and its interference MIC microbial induced corrosion such as SRB or general anaerobic bacteria. In general, Our KPI target is to reduce organic acid content by neutralization method. By doing this, it should reflecting the corrosivity reduction on LPR measurement at the most downstream weststream pipeline. For example, if we take the sample here, sample from LPR measurement corrosion. As you can see, we are suggesting the general KPI to protect and mitigate from organic acid corrosion. It consists of 95% of data analytical availability and continuous interpretation KPI. And then 95% of analytical equipment availability KPI and 95% surveillance to all location identified content threat corrosion from organic acid KPI, and 100% analyzer calibration and verification to sustain confidence analytical measurement KPI. Next is 95% training awareness to operator on organic acid corrosion and its interference to gain the asset ownership. And lastly, in general KPI is continuous chemical-based enhancement, collaboration, and optimization to ensure treatment organic acid and its salt at the best value to minimize the corrosion. For the KPI dashboard organic acid corrosion monitoring, we can see here we suggest to put the efficiency of organic acid removal percentage and tune corrosion rate by LPR measurement, and then surveillance site percentage of training organic acid, analytical equipment availability, and general corrosion grade as per NIST RP 0775-2005 specification, and average interference by microbial induced corrosion by SRB or GANB. This is the end of my video presentation. Hope it will give benefit in the Petronas effort to combating the organic acid corrosion. Thank you.